Every image captured by the James Webb Space Telescope represents a new discovery, offering humanity a view of the universe that has never been seen before. This telescope's exploration of our cosmos stands as one of humanity's great engineering achievements, marking the dawn of a new era in astronomy. Launched after more than 2 decades of meticulous preparation, this $10 billion telescope aims to capture starlight from the earliest galaxies born in the fiery crucible of the Big Bang. Despite experiencing multiple delays, the Webb telescope has finally delivered the goods. However, the latest images captured by the Webb telescope are sending shock waves through the scientific community, as they call our entire understanding of galaxy formation into question. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. Join us as we dig into Webb's newest images, hinting at another universe at the edge of the universe. Humans have long found meaning in the stars, but only recently have we begun to understand whole clusters of them, galaxies way out in the depths of space. A few nearby galaxies, such as Andromeda, have always been visible to the naked eye as a dusky smear in the night sky. Other shimmery structures became known to us after the invention of the telescope in the 17th century, along with a debate about their nature. Were they clouds of cosmic dust within our Milky Way or island universes of their own? Not until the 1920s did humanity identify these glowing clouds as galaxies, when the astronomer Edwin Hubble, relying on the work of a lesser-known astronomer, Henrietta Leavitt, found that some stars were too far away to belong to the Milky Way. And only in the mid-1990s, when a space telescope named for Hubble peeked farther into the universe than ever before, did we find the thousands of galaxies shimmering across the universe, island after island in a vast cosmic sea. After Hubble, astronomers felt pretty confident that they understood galaxies and how nature makes them. But some new, startling developments have recently popped up, courtesy of a space telescope far more powerful than Hubble, the James Webb Space Telescope. In full operation since last summer, it has shown that galaxies formed much sooner after the Big Bang than scientists previously thought, and that some of them are unexpectedly large, absolutely brimming with stars. The findings have thrown scientists into a new reality in which their existing theories no longer apply. Everyone in the astronomy community knew that the Webb telescope was going to be revolutionary. The whole concept of the James Webb Space Telescope was to see the universe the way no previous telescope had ever seen it, and the new images from the Webb telescope truly stunned the field of astronomy. One of the first papers on JWST data came from Naidu, the MIT astronomer, and his colleagues, whose search algorithm flagged a galaxy that seemed inexplicably bright and unaccountably distant. Naidu dubbed it Glass Z13, indicating its apparent distance at a redshift of 13, further away than anything seen before. The galaxy's redshift was later revised down to 12.4, and it was renamed Glass Z12. Other astronomers working on the various sets of JWST observations were reporting redshift values from 11 to 20, including one galaxy called CEERS 1749 or CR2Z17-1, whose light appears to have left it 13.7 billion years ago, just 220 million years after the Big Bang, barely an eye blink after the beginning of cosmic time. These putative detections, if confirmed, may challenge the standard model of cosmology, called lambda CDM or LCDM. This model incorporates scientists' best estimates for the properties of dark energy and dark matter, which collectively act to dominate the emergence of large-scale cosmic structures. Lambda refers to dark energy, and CDM refers to dark matter that is relatively sluggish or cold. Even if you took everything that was available to form stars and snapped your fingers instantaneously, you still wouldn't be able to get that big that early, says Michael Boylan-Kolchin, a cosmologist at the University of Texas at Austin. It would be a real revolution to understand the dilemma. In a study published in Nature Astronomy, Mike Boylan-Kolchin, an associate professor of astronomy at the University of Texas at Austin, finds that 6 of the earliest and most massive galaxy candidates observed by JWST so far stand to contradict the prevailing thinking in cosmology. That's because other researchers estimate that each galaxy is seen from between 500 and 700 million years after the Big Bang, yet measures more than 10 billion times as massive as our Sun. One of the galaxies even appears to be more massive than the Milky Way, despite that our own galaxy had billions of more years to form and grow. If the masses are right, then we are in uncharted territory, Boylan-Kolchin said. we'll require something very new about galaxy formation or a modification to cosmology. One of the most extreme possibilities is that the universe was expanding faster shortly after the Big Bang than we predict, which might require new forces and particles for galaxies to form so fast at such a size. They also would need to be converting nearly 100% of their available gas into stars. We typically see a maximum of 10% of gas converted into stars, Boyle and Kolchin said. So while 100% conversion of gas into stars is technically right at the edge of what is theoretically possible, it's really the case that this would require something to be very different from what we expect. For all of the breathless excitement it evokes, JWST has presented astronomers with an unsettling dilemma. If the masses and times since the Big Bang are confirmed for these galaxies, fundamental changes to the reigning model of cosmology, called the dark energy plus cold dark matter lambda CDM paradigm, which has guided cosmology since the late 1990s, could be needed. If there are other faster ways to form galaxies than lambda CDM allows, or if more matter actually was available for forming stars and galaxies in the early universe than was previously understood, astronomers would need to shift their prevailing thinking. The 6 galaxies' times and masses are initial estimates and will need follow-up confirmation with spectroscopy, a method that splits the light into a spectrum and analyzes the brightness in different colors. Such analysis might suggest that central supermassive black holes, which could heat up the surrounding gas, may be making the galaxies brighter so that they look more massive than they really are. Or perhaps the galaxies are actually seen at a time much later than originally estimated due to dust that causes the color of the light from the galaxy to shift redder, giving the illusion of being more light years away and thus further back in time. Of course, further investigations into the 6 universe breakers are required. Astronomers are confident that the Webb telescope's near-infrared spectrograph, NIR-SPEC, which surveys temperature, mass, and chemical composition of target objects, is more than capable of providing a conclusive answer regarding their existence. In the meantime, let's admire the new stunning photos taken by NASA's Time Machine. The Webb telescope has imaged 7 galaxies that comprise a massive galactic cluster in the early stages of its evolution. The galaxies are seen as they were just 650 million years after the Big Bang, meaning they make up the youngest so-called protocluster ever seen by astronomers. The protocluster will eventually grow in mass and size by incorporating galaxies, forming a galactic cluster that resembles the Coma cluster, which NASA describes as a monster of the modern universe. The observation of these 7 galaxies could therefore help scientists better understand how the cosmos has evolved over its 13.8 billion-year existence to take the form we see in the local universe today. This is a very special, unique site of accelerated galaxy evolution, and the JWST gave us the unprecedented ability to measure the velocities of these 7 galaxies and confidently confirm that they are bound together in a protocluster, said research lead author Takahiro Morishita, a scientist at the Infrared Processing and Analysis Center at the California Institute of Technology in Pasadena. The team was able to determine that the galaxies are moving at over 2 million miles per hour, or 3.2 million kilometers per hour, about 1,000 times faster than a bullet fired by a rifle, through a halo of dark matter. The key to doing this and to determining the distances between the galaxies were precise measurements captured by Webb's near-infrared spectrograph, NIR-SPEC. The NIR-SPEC data allowed the team to model how the galaxy group develops over time and build a picture of what this cluster should look like in the modern universe. They predicted the protocluster will resemble the Coma cluster, meaning it could now be one of the densest clusters of galaxies in the cosmos, with thousands of individual member galaxies. We can see these distant galaxies like small drops of water in different rivers, and we can see that eventually they will all become part of one big, mighty river, team member Benedetta Vulcani of the National Institute of Astrophysics in Italy said in the same statement. Galaxy clusters are the greatest concentrations of mass in the known universe, which can dramatically warp the fabric of spacetime itself. This warping, called gravitational lensing, can have a magnifying effect for objects beyond the cluster, allowing astronomers to look through the cluster like a giant magnifying glass. The research team was able to utilize this effect, looking through Pandora's cluster to view the protocluster. Even Webb's powerful instruments need an assist from nature to see so far. Exploring how large clusters like Pandora and Coma first came together has been difficult due to the expansion of the universe stretching light beyond visible wavelengths into the infrared, where astronomers lacked high-resolution data. Before Webb's infrared instruments were developed specifically to fill in these gaps at the beginning of the universe's story. The 7 galaxies confirmed by Webb were first established as candidates for observation using data from the Hubble Space Telescope's Frontier Fields program. The program dedicated Hubble time to observations using gravitational lensing to observe very distant galaxies in detail. However, because Hubble cannot detect light beyond near-infrared, there was only so much detail it can see. Webb picked up the investigation, focusing on the galaxies scouted by Hubble and gathering detailed spectroscopic data in addition to imagery. The study of such protoclusters in the early universe could get a massive boost when JWST teams up with another powerful telescope in the future. That's all the information that we have for you today. Don't forget to give us a thumbs up if you've enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. Be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.